example 1.30. In a very similar manner to example 1.20, we aren't going to talk through the algebra or how to solve these limits when we have this indeterminate form. Here, I just want to give us an example of which the indeterminate form, infinity plus or minus infinity, yields either a limit could exist or a limit could not exist. So it's inconclusive if we get this indeterminate form. Let's look at the first function, f of x, which is x squared minus x squared. So if we take the limit as x approaches positive infinity of x squared minus x squared, and we attempted direct substitution immediately, we end up with the indeterminate form infinity minus infinity. So this is not a real number. It does not exist. So we have a limit that does not exist in our initial attempt. So the initial attempt was just direct substitution. However, what we should have done, let me switch colors, is simplified with some algebra first before we take our limit. So x squared minus x squared is obviously just 0 for all x values. And what happens to the constant 0 as x travels to infinity? It stays 0. It's a constant 0. In fact, you might look down here and think that the graph of the function is not there, but it is there, right? X squared minus x squared is just equal to 0. So the graph of this function is hiding behind the x-axis. So here, the limit exists for all points. It's equal to 0 because the function is constantly equal to 0, even though your direct substitution gave you the indeterminate form infinity plus or minus infinity. Let's go over here. G of x, which is x squared minus x. So again, let's just try direct substitution first. If I attempted to take the limit as x travels to infinity of x squared minus x, we get infinity minus infinity. So again, another indeterminate form. The limit may or may not exist. But we can see if we take the limit as x goes to infinity, and we simplify with a little bit of algebra first, and I pull out the x. Actually, I would like to pull out the x squared. We end up with the limit that looks like the x squared function. In fact, this should just be a review of what you learned in algebra. The end behavior of a polynomial is dependent upon the leading term, so the x squared term. And we look at the graph of this function, and we see that as x travels to infinity, this direction, our graph grows without bound to positive infinity. So the limit of g of x is positive infinity, which does not exist, or at least is not a real number. So here we have two examples. Both give us the indeterminate form, infinity plus or minus infinity, one of which has a limit, the other of which does not give us a real limit.